I apologize. Oh, yeah, another one. I apologize for the last recording. Emily told me to post it, and I was looking all over. I couldn't find it, so it didn't work. And anyway, so I posted a video from my Math 2040 class. At the end, there was some stuff you guys don't need to worry about, but did that help everyone? Okay. So I apologize, but hopefully we're recording today. Okay. So today's lecture, let's see here. I'm going to go over here. Is on chapter, where are we on, 16, I think? This is going to be confidence interval for a mean. Okay? All right, so the basic form, remember the basic form is some sort of a point estimate plus or minus some sort of a margin of error. You guys remember that from last time? That was like 2 weeks ago. You can't remember that, right? It's flushed. Okay. All right. So we're going to follow that basic thing, but I'm going to give you not one but two more formulas. Okay. Now, the key question you should ask yourself when you're doing a mean is, the key question is, do I know the population standard deviation? There's only two answers to that question. What are the two answers? Either yes or no. Yes or no. Okay? If the answer is yes, we're going to use the z distribution just as we have in this class always. If the answer is no, we're going to use the t distribution. So I'm going to introduce a new distribution to you today. Okay? Now, the t distribution is similar to the z distribution. Okay, and in fact, I'll tell you some of those similarities in a minute. The formula for the z distribution and the t distribution are very similar. Okay, so let me give those formulas to you. So if you're using the z distribution, the formula is going to be x bar. We're using x bar rather than p hat now. Okay, plus or minus z sub alpha over 2 times sigma over the square root of that. So you can think of this, once again, this is your point estimate, and this piece here is your margin of error. Okay? The formula, if you're using the t distribution, is going to be very similar. It's going to be x bar plus or minus t sub alpha over 2 times s over the square root of that. So you can see those formulas are very, very similar. One's a z, one's a t, one's a sigma, one's an s. Okay? Yes?
What sigma stands for again?
What does sigma stand for? Which standard deviation? Population standard deviation. What does s stand for? Sample standard deviation. Okay? All right. So, all right. Oh, that's the homework. I was like, I already did that. Okay, so let's talk about some requirements. I should turn this over here. Oh. Okay. So the requirements, the data, actually, let me do this. I can't tell if I'm, yeah. Requirements. Number one, the data comes from a simple random sample. Number two, it comes from a population that is normally distributed, and your n should be greater than or equal to 30. Okay? Yes.
Is that a requirement for all of that, or just like the yes or no? Does that make sense what I'm asking?
It's for both.
Okay.
Now, it should be. However, I'll give you a caveat here. However, you can get away with smaller samples if you do what's called a QQ plot. Okay, so you can get away with that. But basically, if I tell you it's normally distributed, you can also get away with that. Okay, so we're not going to teach you QQ plots. If you want to learn a QQ plot, come to my Math 2040 class. Summer semester, it'll be fun. 6 weeks. You thought this class was fast, or 7 weeks, I guess it is. You imagine, that's like sucking on a fire hose. Like, it comes fast. Okay. All right. All right. Now, so those are your main requirements. So I'm not going to worry too often. In real life, you should generally try to get your sample greater than 30. However, let me tell you a real life example. So sometimes you can't. Okay, so a real life example, in one of my online Math 2040 classes, one of the things that we used to make people do was we made them watch this 2-hour-long video called Super Croc. Okay, it was about crocodiles. So apparently in Africa, they found a crocodile head in the desert, which meant that Africa at one time was a swamp, and it was now a desert. The head, they only found the head of the crocodile. The head was 6 feet long, as big as me, the head. Can you imagine how big that crocodile was? Now, they didn't know the rest of the body length. They only had one crocodile head, okay? You don't get to increase your sample size, okay? So they wanted to figure out, well, if this was like a modern day crocodile, I mean, this was a dinosaur, obviously. If this was like a modern crocodile, how would we figure that out? And so the video talks about how they do that. And plus they got lots of snapping crocodiles and things like that. So it's pretty exciting. It's 2 hours long. It's 2 hours long, yeah. The statistics didn't take 2 hours, but the video was pretty interesting. And the problem was with the video site that they use, like if you stopped watching it like an hour through, then you had to start over and watch it again. It's just so ridiculous. But at any rate, so when they took a bunch of crocodiles, like modern crocodiles, and they compared their head length to their body length, and they tried to estimate how long that crocodile was. How long do you think it was? 40 feet long. Can you imagine? Like they took up a whole, it took up a whole room, and they're like, "Are you sure it was this big?" And I was like, "That's our calculations." And they're like, "It was huge, unbelievable." So at any rate. So sometimes you don't get bigger sample sizes. Most of the stuff that you guys should be able to. Okay, by the way, let me ask you guys a question. How are you guys done collecting your data? Okay, so last week was a good week for that. But yeah, so make sure, so you should start collecting your data. The stuff we learned in chapter 15, you're going to be doing a confidence interval, so you should be able to start calculating a confidence interval for your data. Do it at the end of the semester, but you don't want to wait till the end of the semester. You want to. Yeah, we'll probably talk about that. Probably next time for the review, we'll talk more about that. But anyway, just start thinking about that because we're going to do a hypothesis test on it as well as a confidence interval. But you should be able. You have enough knowledge that you should be able to calculate a confidence interval now. Yes. What'd you say?
When's the test? Like what day?
The test is going to be a week from today. I haven't scheduled it in the testing center, but it'll probably be like Wednesday, like Tuesday, Wednesday, or Monday through Wednesday, or something like that.
What
So
chapters will it cover?
it will cover everything from the previous test up through today.
You don't remember.
I think we stop at 12.
Because I don't remember.
So it'll be like 13 through 16. It's actually going to be a little shorter, but a lot harder. Okay, so you got to study hard. All that stuff you forgot last week during spring break, you got to cram it. Okay. All right, now let's talk a little bit about the t distribution. Okay. Number one, the t distribution. The third requirement, well, that doesn't matter, because either you know your sigma, if sigma is known, it's a z. If sigma is not known, it's a t. I mentioned that before. You can write that down, but yeah. All right, number one, the shape depends on the number of degrees of freedom. Okay, now that's going to make you ask what degrees of freedom are. I'm going to give you a new 2 here on my notes here, but your degrees of freedom, abbreviated DF, equals your sample size minus 1. Okay, number 3, it is symmetric about the number 0. Number 4, the area under the curve, I bet you guys can guess, equals 1 or 100%. Number 5, make sure I'm still on here. Okay. Oh, I guess I didn't get, oh no, I did. Number 5, as t approaches, let's see, as t increases at each end, the curve approaches 0. Number 6, the area in the tails is greater than the normal distribution. And number 7, as n increases, it looks like the normal curve. Okay, so basically the t-distribution looks a lot like the z-distribution, but your tails are bigger. There's a website out here, and let me see if I can find it here. Oh, I need to share. Let me share first. All right, so if I go out here to all right, so here's an example of a t-distribution, and it looks pretty cool. So you can see here, here's the normal curve. So this is a t-distribution with 3 degrees of freedom. You can see that the tails are a little bit bigger on the out here on the t-distribution than they are on the z-distribution, the normal distribution. So it looks a lot like this. It was discovered by a person named William Gossett. He actually worked in an Irish brewery. And he wanted to deal a lot with small sample sizes, okay? So he kind of wanted to be able to get away with sample sizes less than 30. And so this works very well for that. But the problem is your shape changes. You can see if I go from 3 degrees of freedom to 300 degrees of freedom, you'll see that those curves actually are pretty much on top of each other. So as your n gets really big, but as your n gets small, you can see that the curves are a little bit more different. Okay? Does that make sense? All right. So let's see here. Is there a question?
Can you explain what DF equals n-1 again?
Degrees of freedom. DS stands for degrees of freedom equals your sample size minus 1. Okay, so here's what I'd like to do. So I'm going to introduce to you a new formula. I'm going to concentrate more on the t-distribution because I think you understand the z because we've got over that quite a bit. Yes?
Can you remember what SRS is?
Simple random sample. Okay? So yeah, we're always assuming it's a simple random sample. Okay, all right. So find the t-value such that the area under the t-distribution, maybe I should pass these back out. I shouldn't have collected these formulas. Do you guys want to look at these, or do you want to just see it on the computer screen? Just the computer screen is fine? Okay. So here's your formula sheet. Okay, so as we're looking here at this, oh, that's just the first page. This is the one I really want to look at. Oh, I thought it was. Here, I'll just do it in Excel because I know it's a little easier. And the nice thing about Excel, I've got this in Excel and it keeps your things. Okay, so let's say, for example, that I want you to find the area with 10% to the right, and I'm probably not aiming my video over there, and 15 degrees of freedom. Okay, so if we're looking here, now by the way, let me just mention this really quickly. I'll make that bigger. Notice this picture at the top of your page here. It gives you the area to the right. The normal distribution gives you the area to the left. Okay, so these charts are kind of backwards. Okay, now once again, the t-distribution is going to be symmetric just like the normal distribution. Okay, so the idea here is, as you're looking here, okay, I want 10% to the right. So I'm going to be looking in this first column here. That's not the first column, that's actually the fourth column. Okay, fourth column here, and I want 15 degrees of freedom. Okay, so that value there is 1.341. Okay, now let me give you a small difference here. What if I said, instead of to the right, I wanted to the left? I want 10% to the left. So in this case, because it's symmetric, your value in this case would be negative 1.341. Okay? So you can think of this just like we do with the plus and the minus. Because your t-distribution is centered here at 0, if I go negative 1.341, you can think of this as standard deviations. And that's going to give me 10% to the left, and if I go to positive 1.341, that's going to give me 10% to the right. What kind of a confidence interval would this be? This would be 80% in the middle. 80% confidence interval. Does that make sense? Okay. All right. So let's do an example here. All right, here's my example. So my example here, I'm going to copy this so I don't have to type it. Okay. All right. I'm just going to copy and paste this. Okay, so an arborist wants to determine the mean diameter of mature white oak trees. The data represents 7 mature trees 1 meter above the base. Treat this as a simple random sample and construct a 95% confidence interval. Here's your data here. Now here's what I'm going to do. I'm going to fix my data. Text to columns. Normally I'm not going to put commas in here. Okay, so I've got a bunch of data here. Now for some reason this person only collected 7 trees. I'm sure there's a lot more than 7 they could have done, but we're trying to illustrate here. So 7 mature oak trees, we've got a small sample size, but we're treating this as if it is normally distributed. Okay? All right, now the first question when you're doing this is what? What should you ask yourself? Do I know the population standard deviation? What do you think, Ashley? No. So therefore, because I don't know it, is it a Z or is it a T? It's going to be a T distribution. So I'm going to be using this second formula here in blue. Does that make sense? Okay. Now, in order to do this, I need to know the X bar. I need to know the T sub alpha over 2. I need to know the S, and I need to know the N. Okay? So Elizabeth, how do I find the X bar?
Is it 7?
What'd you say?
7?
Of those 7 trees.
Yeah.
So how do I find that?
I don't know, I remember us going out. Add them together and divide.
Add them together and divide by 7, right? Oh, do you remember the Excel command? Average. Curse Bill Gates when you see that, okay? All right, equals the average of those. So the mean height, or the mean diameter of mature oak trees is 49, probably centimeters, okay? T sub alpha over 2. There's 2 ways to find this. You can either find it with the computer or with the table. Let's do the table first. Okay, so if I go here to the table, okay, I'm looking for a 95% confidence interval. If it's 95% here, how much should be in the tails? I want 0.025 on the right, and I want 0.025 on the left. Okay, so which column am I looking at on my table? .025, this column I here, right? Okay. Oh, so actually so the other thing I need to know here is my degrees of freedom, right? What's my N in this case? 7 was my degrees of freedom. 6 degrees of freedom. Oh, by the way, what's my S? How do you figure that out quickly and easily with the computer? STDEV, which one? The dot S if you want, or just plain old that, and then you highlight your data. I won't make you figure out the standard deviation until the final exam by hand. Okay? Is that a deal? Are you going to learn it by the final exam? Okay, you've been warned, it's on video. Okay? You can't say I didn't warn you. Okay, so the standard deviation is 13.79. All right, so if I'm using the table, I've got 6 degrees of freedom, 95%, I'm looking at the 0.025 column. Okay, the 0.025 column, 6 degrees of freedom, that gives me that value 2.447. Do you see that? Okay, 2.447. Okay, yes.
Did you get the 6 for the degrees of freedom?
N minus 1.
Oh, never mind.
Okay. All right. Now, if you do the computer will tell you this as well. The command for the computer, by the way, it's written on your formula sheet on the front page. Just a reminder, you don't need to go searching through help. It's on this page. I gave it to you. Okay? Don't let the testing center call me and tell me you're cheating because you're going through the Excel help. It's right there. Okay? That happened on the last test. I ignored it. I just said, yeah, they don't know what they're doing. They're not going to do well on the test anyway. Okay? So the command is t.inverse. Okay? And do we want a one-tailed or a two-tailed test? What have I drawn here? This is a one or a two-tailed test? Two tails. I got 2 tails highlighted here, right? Okay? So we're going to use 2t. Okay? The probability. How much do I want in between the tails? What kind of a confidence interval am I making? 0.95, right? I want 95% in between my degrees of freedom. I can either type 6 or I can click the 6. Okay? it should give me 2.447 plus more digits. Oh, sorry. Never mind, I told you wrong. You want 0.05 there. It's how much is in the tails, not between the tails. So you want 0.05 here, that gives me 2.446912. Okay? Does that make sense? Well, yeah, 0.05. Okay? So you can think of this essentially, now these numbers are wrong here. How many sort of standard deviations am I away? 2.447 and minus 2.447. Does that make sense? Okay. Okay, so I have everything I need to do. Okay. So now I'm going to create a lower. I'm going to create an upper. Okay, it's always the lower number first. Okay. So, Ashley, can you help me type in this formula? Equals X bar in this case is 49.085 minus T. Which T do you want to use? You're using the more accurate one, so it gives you more digits. Okay. The other one's fine too. Now what?
Does it say or do Z?
X bar minus T sub alpha over 2. What happens next? Times S. What's S?
The standard,
13.7957 divided by the square root of 7. Close your parentheses. Now parentheses are very important. Okay? All right. So now can I copy and paste this? Sort of. I just copied it the wrong way. I did that on purpose so you'd know not to do that. Okay? If you want to copy it, don't copy here. Copy up on your formula bar up here. If you highlight that, if you press Control C, and then you go over here and you press Control V, you should get the exact same number. What's the only thing I have to do to change the formula now? Change that minus to a plus. Okay. Now, Hannah, can you give me a confidence statement? Is between, say it again. So here's what I would do. At least go one more digit than they gave you. So they got one decimal there. So do 36.33 to 61.84 centimeters. Or whatever the unit is. It didn't really say, but I'm pretty sure it's in centimeters. Okay? Does that make sense? Are you going to ace my test? Okay.
Are you gonna do it in Excel as part of Excel or by hand?
Yes, I'll do it both ways. Okay. Do you want me to do the next one by hand on the board? Okay. Let's do one by hand on the board. But yes, either way that'll work. By the way, if this was a Z distribution, what would be the command? Rather than T inverse 2 tails, it would be norm S inverse. Just for fun, if I put in 0.05 or 0.025, that will give me 1.96. Okay, that's the same number that's on my table here. If I go to my normal table, 1.96. It's actually 1.95996. Okay. All right. So let's do all those things are on your formula sheet. Now here's what I would recommend. When you're doing your homework, do it twice. Do it once with the computer, do it once by hand, because I'm going to test you both ways. Okay? If you're using the paper test, I'm going to expect that you're going to use the chart. If you're using the computer test, I'm going to expect you're going to use the computer. Okay? So that's the rule. It's on video. You can't say I didn't tell you, I'll just say look at the video. Okay? Only Emily looks at the video because she told me it wasn't even up. Okay? All right. Let's do another example then. Okay. Residents are concerned about the speed limit and want to estimate the population mean of the cars on the highway with a speed limit of 45 miles per hour. They track 12 cars and find the X bar to be 59.62. Oh, you know what? I'm going to do this. I'm going to change this problem a little bit. The highway patrol tells them the standard deviation is 5.3 miles per hour. Okay. Now, do I know the population standard deviation? Who says yes? 1, 2, 3. Who says no? 4. Who says no? 1, 2. There's more than 6 people in this room. Who didn't raise your hand? Only 2 honest people. Okay. All right. So yeah, the highway patrol tells you the standard deviation. We're assuming that's the population standard deviation. Is this going to be a Z or a T test? Z test. Okay. So let's stop sharing. We're going to do this one on the board so you guys know how to do this. Now in this case, we're using this formula here, the green formula. Okay. So let's pick on Aaron. Can you help me do this? Okay. What do I need to know? I need to know my X bar. My X bar, it told me, was 59.62. I'm going to need to know my Z sub alpha over 2. I'm going to need to know my sigma, which I do know my sigma. It is 5.3. And my N, oh, I didn't say how many cars, or did I? Oh, 12 cars. N is 12. Do I need to know degrees of freedom on this one? No. Okay. So I'm using my chart now. So how do I use my chart? If I go to my chart here, okay, what value do I use? If I don't tell you what confidence level, assume it's 95%. So your alpha over 2 equals 1.96. Your Z sub alpha over 2. Okay? Oh, I wrote it on there twice. That's right. Okay? All right. So now, let's pick on Laura. Can you punch this through for me?
So, yeah, 59.62.
9.62 plus or minus.
Times 5.3 divided by square root of.
Times, you said divided by, but you meant times, right?
Yeah, I said times, but then I said.
Oh, times
then
5.
I said 5.3 divided by the square root.
You divided by the square root of 12. Okay, so hopefully you can all plug that in your calculator. Okay, I'm going to use my favorite calculator, Excel. Equals. Oh, I did. Yeah, we did leave out the 1.96 in the formula. 1.96 times that. Okay. So minus 1.96 times 5.3 divided by the square root of 12. I'm going to copy, I'm going to paste that one, I'm going to change that minus to a plus. Okay. So, who do I want to pick on? Steve, it must be your turn. Can you give me a confidence statement?
With that same one, 95%.
Uh-huh.
We're 95% confident that That'd be the 56.62.
At the mean speed limit,
Sorry, no speed limit.
mean speed, not limit, but the mean speed
Yeah,
of cars on this road,
it's between
56.62 and
63.6.
2.62 miles per hour. Okay, so if the speed limit is 45, would you feel confident that these cars are speeding? Yes, because both of these values are above 45, right? So we need to get people to slow down. Okay? Now, let me ask you a question. What if I wanted a 99% confidence interval? Would your margin of error go up or down? Or before I ask that question, okay, would margin of error increase or decrease? And you may say, what is your margin of error? What would be the value of the margin of error in this case? In the let's do the 95 first. So your margin of error equals what? Let's look back here at your formula. Okay, remember I told you at the beginning of class, it's the point estimate plus or minus the margin of error. What's your margin of error in my formula? It's this piece, it's this box right here. Or it's this piece right here if I'm doing the t-distribution. Okay, so could you calculate the margin of error? Alina, could you do that? Okay. What is it? You're calculating it already? You're going to tell me how to calculate it? Because Caleb wanted to know. $2.998. How did you get that? Equals 1.96 divided by the square root of 12. Oh wow, how about that? Okay, does that make sense? Could you do that, Caleb?
Hope so.
Okay. Now we know that on a 95% confidence interval, it is about 3 miles per hour. Okay, if I round that up to 3. On a 99%, would it be higher than 3 or lower than 3? Should we vote? Who says it's going to be higher than 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Who says it's going to be lower? 2? Okay, 3, 4. Okay, how would we calculate it? We can calculate it and prove the answer here. See if the majority or the minority are correct. Okay? We change the 1.96 to what? Okay, we're gonna multiply it by a 99. We're gonna multiply it by a bigger number. What's that gonna do? It's gonna make it bigger. Okay, so instead of 1.56, it's now 2.575. It's almost 4 miles per hour. It's gonna be bigger. Okay, So it's going to increase it. Or it increase it. Okay, does that make sense? Okay. So yes, if you're more confident, you're going to have to give yourself more room for error. Okay. I think I told you this before spring break. I am 100% confident that Donald Trump's approval rating is somewhere between 0 and 100%. Prove me wrong. Okay. I give myself a huge margin of error. I can't be wrong, right? So the more confident you want to be, the bigger your margin of error. Okay. 30% confident that it's greater than 50%. Which means there's a 70% chance I could be wrong. Okay. But yeah, let's rephrase that. I'm 30% confident it's between 55 and 65%. Much smaller margin of error, much less confidence. Okay? Does that make sense? All right. Is there anything else I want to cover? About out of time. Okay, so I did this one here. Oh, I did it with 8 miles per hour instead of 5.3. So I did that example there. All right. So we got about 5 minutes left. Do you guys want to ask me any questions? Yes.
Just about our project. We haven't gotten an email from them or if you did.
I haven't either. Okay. Send me an email to remind me, or I'll try to email them right now. I can't remember. Yeah. I haven't heard back from them either. Is there anybody else who's not been approved? Have you been approved by me? Well, if you haven't been approved by me, then I think they have. You've been approved by me.
Yeah.
If you haven't been approved by me, I haven't given it to the IRB. Okay? All right. Any other questions? Okay. All right. So quiz on Thursday will be on chapter 16. We'll do a review on chapter 16 on Thursday. The test will be next week. I'll tell you for sure because I don't think I put it in there yet, but I'll tell you for sure on. It's probably the computer. Probably Monday, Tuesday, Wednesday, and then the written test will be Tuesday in class. So plan on the written test for sure Tuesday. I'll have to check with them for scheduling. Okay? Yes, Steve.
I'm sorry, the last chapter is 13.
13 through 16. Okay? All right. See you all on Thursday.